Students, in this part and all the upcoming videos will include the properties of water, which is the most abundant and essential chemical compound on our planet. Water's unique chemical properties make it an excellent compound, playing a crucial role in various biological, chemical, and physical processes. So let's dive deeper into the fascinating world of water and explore its incredible properties and functions. Well, 71% of our Earth is covered with water, and only 29% of our Earth is covered with land. If we talk about this 71% of water, that mostly includes water in the form of ocean water. And we know that ocean water is salty and we cannot consume it, neither can we neither can we use it in our daily lives. While the rest of the 2.5% of the water on our earth is present in the form of fresh water, and we can consume fresh water. Well, this fresh water is also not very abundant for us because 68% of this water is present in the form of glaciers, and these glaciers they may be present in the polar regions of the earth like Antarctica or Arctic, or they may be present in the highest peaks or highest ridges of the world, including Himalayan range and some other mountainous areas of the world. The rest of the 30% of water is available for us in the form of groundwater, and the other 0.8% and 0.4% water is present in the form of permafrost and atmospheric water in the form of clouds and moisture. Well, if you want to know about the difference between the groundwater and permafrost briefly, so look at this picture. Now, this is surface water, and surface water is, we can see surface water in the form of lakes, in the form of rivers, or streams, or ponds. So we can see that, and that is the fresh water. Well, when the water table is present below the ground, as you can see here, so this water table below the ground in the soil, it is called the groundwater. So that is still water, I mean running water, and we can consume it by digging a well or using electric motors and various other methods. Well, if we talk about the permafrost, that is entirely a different thing. Permafrost is a mixture of wait. Permafrost is a mixture of sand, soil, and ice, and and of course rocks as well. So this frozen mixture of sand, soil, ice, and rock, that is called a permafrost. So that is a frozen mixture. That is present, of course, that is present way below the surface level, but we can, if we in the regions where there is a high possibility of finding the permafrost, of course, in the colder regions of the world, if we dig a hole in the earth, or if we dig a ground, we can see a layer of permafrost there. Well, the properties of water in our body and in our ecosystem, they are all due to the chemical and physical nature of water. And by chemical and physical nature, I mean the bonds that are present between the atoms in the water and the bonds which are present between the molecules in the water. So, chemical properties, they are due to the bonds, while the physical properties, they are due to the intermolecular forces. If we talk about the structure of water, well, we all know that water is H2O, meaning that two hydrogen atoms, they are linked with an oxygen atom, and the bond that they share is called the covalent bond. If you remember from the very first lecture, covalent bond is covalent bond is made when two atoms they share their electrons. But in case of water, this bond is not, or this sharing of electron is not equal. The oxygen because of its high electronegativity, has more attraction for this shared pair of electrons. And that is why oxygens get a partial negative charge while the hydrogens they get a partial positive charge. It is due to the high electronegativity of oxygen. And if you guys remember what electronegativity is, it is the ability of an atom to attract electrons towards itself. So take a look at this example of hydrogen and chlorine. So in the hydrochloric acid or in the hydrogen chloride, because of the high electronegativity of chlorine, chlorine has attracted this shared pair of electron towards itself. And that is why the electronic cloud on the chlorine is greater than the electronic cloud on the hydrogen. And due to this electronic cloud, the chlorine it gets a negative charge while the hydrogen gets a positive charge. The same things happen in case of the water molecule. And by the way, that is the reason why we call the water molecule as a dipole molecule, because there are two poles, a positive pole and a negative pole. Well, if you talk about the bonds between the molecules of water, of course, water is present normally at the room temperature, or most of the temperature that exists on the earth and in our body. Water is present in liquid form, and the liquid form is attained by the water molecules when, of course, they have developed intermolecular forces between them. So this is one molecule of water, and these are the other molecules of water. Now, these are the bonds that are present between the water molecules. These are, of course, strongest covalent bonds. But the due to the partial negative charge on the oxygen and partial positive charges on the hydrogen of one molecule also faces attraction toward the oxygen of other molecule. And this is why they develop an attractive force toward each other. That attractive force is called the hydrogen bond. And if you also remember the lecture where we talked about the hydrogen bond or the definition of it, so hydrogen bond is basically an intermolecular force between hydrogen of one molecule and the oxygen, let's say, or a highly electronegative atom of the other molecule. So this highly electronegative atom, it could be an oxygen atom, it could be a nitrogen atom, or it could be a fluorine atom. So because these elements they have the highest electronegativity in the periodic table. So whenever hydrogen of one molecule develops a force with the oxygen, nitrogen, or fluorine of other molecule, then that is called the hydrogen bonds. And hydrogen bonds, well, they are weaker than the covalent bonds, but they are still the most strong intermolecular force. In terms in if we compete the intermolecular forces, then the hydrogen bonding is the strongest one, but of course hydrogen bondings they are not stronger as compared to the covalent bonds. But because of the hydrogen bonding being the strong intermolecular forces, it is very difficult to break this bond. And for breaking this bond, we need a lot of energy. And this factor contributes to too many important properties of water that we are going to study in our next lectures. So we can summarize that water, all of the properties of water, they are due to two things. First, the polarity of water molecules. Polarity means the presence of partial negative and partial positive ions in the water molecule. And the next thing is the presence of hydrogen bonds between the water molecules, which are very strong intermolecular forces.